Okay, looks like we're basically right at 1 o'clock, so let's go ahead and get started. I'm going to take you through today figuring out what your project is, and so basically that amounts to figuring out what the broad topic is. So let's begin. So we're going to begin by taking a look at the readings. So that's your first job, is to go through the assigned readings. The simplest way is just to go through the home page, and you'll notice that I've added over here a claim your topic. So I'm going to ask you to this week to choose something. Okay, so we'll talk about that as we go. Excuse me. Click on readings. Right, that's everything we have so far to get started with. So let's go back and review where we are with the project ideas. Okay, through assignments and the projects page. All right. So here we are. Through the projects page, you'll see your link to the claim your topic. So let's take a look at that. Huge area to go through. Let's go ahead and sort of assign you a topic, right? At least a topic area. So I broke it down for our sake of discussion, 3 general areas. So personal genomics, ancestry, and then culture and identity as it pertains to this topic of personal genomics, ancestry, however you want to put it, right? And so what I'm asking you to do is to claim an area. So all you got to do is choose one of these. So let's say that you're interested in personal genomics, and maybe you're interested in reviewing the idea of how knowing about your genetics can be used in a medical setting. So then your choice would be 1B, right? Personal genomics, precision medicine. Okay. Then the next step, so submit that, okay, and you'll get your 5 points for participation. But the next step then is to sort of investigate this a little bit, and so that's where the readings come in. So let's see if we can go back here. Okay. And what I had promised that we would do today is that I would take you through a reading, how to read these kinds of papers and how to interact with it. Now, you're at the ultimate part of your academic career in terms of getting your bachelor's degree. You've been with us for a couple of years, and you've been taking your chemistry and your biology and your physics classes and your calculus and this and that, and throughout this, at least in biology, I know you've been introduced to some of the scientific papers, right? And in some cases, you've had some good instructions about how to read these things. They're not always the easiest thing to read. So I thought what I would do is I would sort of walk you through how I read papers. Obviously I have a number of years of experience in this subject area, so I have that kind of knowledge base to work from. And so when you're getting started with this, of course, you don't have that knowledge base. And so how do you deal with, you start reading sentences, and pretty quickly you start tripping over the words that you don't understand. And so if you allow yourself to sort of get bogged down that way, you don't make a lot of progress. But on the other hand, if you don't dig into those words that you don't understand, you're missing the whole point about the article. The article is assuming certain knowledge, and you don't have it, so therefore it's going to be hard to actually evaluate the paper. So let's talk about, I selected for this example, I decided let's take a look at the paper that's got one of those clickbait kind of titles, right? What is Ancestry? So let's take a look at that. And I've been looking at it. So what is Ancestry? Well, let's just sort of get to it. And so the first thing that I look for when I start reading papers, I'm looking for section headers. Section headers organize the subject, or at least the material that the authors are going to cover. So I'm scanning through here, and I keep scanning, and I keep scanning. Okay, well, there's the figures, and it's like, oh, my goodness, those figures are not simple to interpret, are they? Well, maybe I can work on that. Well, oh, wait, I was looking for headers. So I'm going to keep going, and I keep going, and I keep going. And already I'm not really happy with the authors. What have I seen so far? 0 headers. So headers give you kind of a guidepost through the material that's going to be presented, and there are no guideposts. There's no map through this. So the good news is this isn't a particularly long article. So the next thing I do, of course, is, well, I'm going to start at the beginning. So we scroll back up here. And we're going to read the first sentence. And ancestry connects genetics and society in fundamental ways. And my heart sinks a little bit because that's not a very helpful sentence. So, okay, we'll cut them some slack. So what do you mean? So for many people, it has cultural, religious, or even political significance. Okay, so that's what they mean by fundamental ways. So we're well on our way. And for you, okay, this is the segue for thinking about, okay, when we're talking about ancestry, cultural, religious, or political significance, that might be the topic that you actually take and run with. The next area is it suggests that it's hinting about 23andMe and Ancestry.com and the rapidly developing consumer genomics field. Okay, so that's another possible way of talking about this. How does 23andMe handle the question about ancestry? Now notice, I'm getting kind of like, I'm firing away from the paper because it starts leading into other suggested ideas, but I'm trying to get you use a paper to generate your own thinking or to ask questions about it. So far so good. Okay. Okay, and in parallel, research about the human past is taking advantage of lots and lots and lots of modern genetic data, okay, which allows us to track changes in ancestry over space and time. Okay, I'm not learning much there, so we move from sophisticated methods. Okay, these are sort of buzzwords. Obviously, saying sophisticated methods is a little intimidating. You shouldn't take it that way, but that's kind of what they're setting you up for, is like, gee, you only can be an expert to understand this. So at any rate, we keep going through here, and I don't see, a lot of help here. I see some sort of throwaway things, but we did come out of that first paragraph with some topic areas that might be more who we can research. All right, so here we go again. So next paragraph. Okay, they're claiming ancestry itself is really defined. Again, I'm not a big fan of sentences like this. This is what we call a straw man argument. When you make claims like this, provide evidence. They don't do that. So I'm going to take a brief break and go back, and one of the things that you should do is what's the expertise that these authors bring to this? So they start us off by saying ancestry connects genetics and society. Okay, so where is their expertise lying? And since this is a genetics journal, you should probably guess that they have zero or very little expertise in culture and society or religious or political implications, but they're geneticists that work in the field. So you can see this is what their funding sources are, and so you'll see NIH, okay? And if you come back up, one of the nice things about the PLOS journals is that you can quickly take a look at the authors. Remember, a fundamental aspect of critical thinking is, can you trust the people who are providing you with information? So one of the things we kind of want to look at is what their backgrounds are, but we also want to look at if they have any potential conflicts of interest. All right, so who are these people? Ian Mathiasen, he's in the genetics department at the School of Medicine at the University of Pennsylvania, and Alwyn Scally, genetics, University of Cambridge. So again, as I sort of suspected, these are geneticists. They're not philosophers. They're not religious scholars. Okay, so to the extent that they, mention those kinds of caveats, we should appreciate that they're not going to be a good source for really articulating what are the implications of genetic research in relation to figuring out ancestry. But what we're going to get from them, go back to the article, is a genetic definition of what they mean by ancestry. Headlines, or the headers, subject headers, sorry, it's hard to sort of figure out what their aim is. And so where they're carving space out, they want to give you a definition, their definition of what ancestry means from a genetic perspective. Okay, and so they go through this a little bit, and then they start talking pretty quickly that the ancestry concept, from their perspective, has at least 3 different meanings. And this is, again, we're speaking specifically of genetics. So there's genealogical ancestry, genetic ancestry, and genetic similarity. So from what we're working on this paper, those are going to be the 3 things that we're going to take away from the paper. That's pretty much the main topic, okay? Is distinguishing and defining those. So we look for, and sure enough, here it is, genealogical ancestry. So what that means is that's basically a family tree or pedigree. Okay, so we already know that. We know what family trees are. Family trees referring to your ancestors. And from the genetic perspective, and somewhere in here, of course, what that's going to mean is that we're talking about only individuals who we are biologically related to. So in thinking about these broader topics, I think you can immediately see how this biological focus can come into conflict with identity, and in a major way, because who we are, our identity, is not necessarily, of course, simply the results or the sum of our biology. So that too is a really pretty interesting area, a topic to dive into. So I encourage you to think about that. All right, so the next couple of paragraphs are defining some terms. So I started to go through here, and it's like, oh, okay, I don't remember what that is. So this is, I encourage you to not read past those. What I want you to do is to look them up, right? And so in our web browser, we can look it up. And so what I find is that this is a religious group, Protestants in France in the 16th and 17th century. There are not Huguenots today, as far as I know. Okay, but that certainly had to do with identity back in the 16th and 17th century. All right, we're going to skip through the graphs because my point today is not to explain this article, but to sort of show how we can read through it. But I did want to kind of point out, like you start reading through the figure legend, and it's got some acronyms in here, and they're not defined. So they're defined in the text, but that's kind of an annoying thing. So I looked it up for you, and it's a type of, so what we're looking at here is an idealized pedigree. And then in B, we're looking at basically looking at genetic ancestry. So the different colors in here would be tracking different chunks of the genome that are shared by this individual with their parents, so red and blue, okay? And then obviously their parents had ancestry. You can track the genetics through as well, okay? And so ARG stand for Ancestral I can't, ancestral recombination graphs. Okay, so if you remember your genetics, basically, the reason that we're not identical copies of our parents is because the gametes shuffle your genetics through recombination. And so that's, in talking about genetic ancestry, you want to be able to follow those chunks of DNA. And so that becomes these much more complicated graphs, B, C, and D. Okay, so what's genetic genealogy? Identifies relatives based on patterns of genetic variation that they share. Okay. So genetic genealogy flows into the idea of genetic ancestry, simply tracking the pieces of DNA, the haplogroups, which they don't actually use that term, but haplogroups, which is large chunks of DNA that are not recombined between in parents' gametes, so they tend to be inherited as groups, right? Okay, what else have we got through here? Well, lots of little things, but so one of the things that I kind of struck, where is it? Okay, so where's the two end part? So if you see what I'm doing, it's like I go through these things and I start making some notes, and it's like, oh, okay, so one of the things we want to talk about is sort of they throw out this thing, if you're going with a pedigree, it's like, well, there's you, and then there's your siblings, of course, if you have them, and then there's your parents, which you may or may not know your parents, but you had biological parents, and they had biological parents, and so on and so forth. And so you can do a quick calculation of about how many ancestors you have by just taking 2 and raising it to the power of n, where n is the number of generations. And then it says somewhere in here basically that this is like an upper limit to the number of ancestors. And so I wanted to kind of point out that this seems deceptively simple, but this is a point where it's missing a lot of value, sort of assuming that you kind of know this stuff. And so if you think about it, okay, how long is a generation time in humans? And it's gotten longer over the number of years that humans have been on the planet. And by the way, modern humans, the science basically suggests that we go back about 200,000 years. All right. Before that, there weren't modern humans. So if we sort of put that as the generation 0, then generation time probably was on the order of about 15 years, long time ago, but now it's about 25 years. So we can just kind of do some simple math and say, well, if we have 8 generations, 2 raised to the power of 8, that means that we have 256 ancestors in our tree. And that actually seems pretty reasonable. But let's think about something a little bigger than that. So let's go back to, basically year 1, AD 1, so the time of Jesus. And so basically to make the math simple, take 2020 and divide it by 25 years. We'll use that as our generation time, and you come up with 80 generations between us and year 1. So if you go 2 raised to the power of 80, you're going to see a problem with how this number works. 2 raised to the power of 80 comes out to be 1.2 septillion, so that's 10 raised to the power of 24. That's an impossible number, okay? And it's impossible for a variety of reasons, but one way to think about it, if you do some quick calculations, how many people have ever lived since 200,000 years ago, and you kind of make some ballpark guesses about birth rates, because of course not everybody has kids, and not every kid survives to have kids, right? So therefore, you don't have this exponential growth. You have something where there's a subgroup of individuals have kids, and so if you take and guess something on the order of about 80 birth rate of like 80 out of 1,000 people, okay, at any rate, what you're going to come to is an estimate for how many people have ever lived on the order of about 100 billion. So 100 billion, that's about 15 times smaller than that 1.2 septillion. Okay, so there's a reason for that. So that number doesn't work. The 2 raised to the n works for going back a few generations, but it doesn't work for going back many generations because of a thing called basically pedigree collapse. And all right, so brace yourself. What that means, of course, is that you're somewhere in your ancestry, distant cousins had kids together. You can think of a variety of ways that happen, but basically it's explained in the Bible too, right? So how many people started at generation 1? It was like Adam and Eve. Okay, so then they had their kids, and then who did they have kids? Their kids have kids with, right? Okay, so that's called pedigree collapse, and it doesn't necessarily mean that we're talking about cultural abnormalities or whatnot. It's just that as populations get large, of course, people lose track of who's related to whom, and you're talking about distantly related people. So at any rate, that's why that number, pedigree collapse, becomes a much more smaller. How many ancestors did you actually have? And it's like, well, it coalesces on a single person. Okay, so at any rate, so that was just 2 raised to the n, but trying to figure out, does that work, took me a little bit, right? Now, I happen to know that, but what I'm asking you to do is to not read past these things, but to try to figure them out. And so this is an opportunity, too. It's like you spend a little bit of time trying to figure it out, and you can't figure it out, so that's something we can talk about together, right? So, for example, how's this going to work? So I looked up ancestral recombination graph. I had some training back in my graduate school days in population genetics, but I wasn't familiar with that term. So it's been a while since I've done population genetics. So one of the first things to do is to see if there's a Wikipedia page for it. So I typed in ancestral recombination graph and started scrolling, and it's like, okay, well, there's the importance of, but there's no Wikipedia page. And I was like, okay, well, that's not good. So let's try a Wikipedia page, add to it. There's not. It's embedded in something else. But then I see this BioWiki thing. So I don't know if you know about this, but some people have created basically glossaries. And so I'm going to click on that. And it's like, okay, well, that's not really helpful, right? There it is. It's a DAG. You're supposed to know what a DAG is? And it's like, no, so I'm going to have to look up that. Now, I happen to know because and this comes from, if you recognize this is part of your graph theory that you were introduced to when you're taking systems biology, or if you're taking some courses in our data science program, you've been introduced at least to a little bit about the idea of graph theory. So DAG refers to, what is it, directed acyclic graph. You with me so far? All right, so let's look that up. It turns out it's not really that hard, but bear with me. Okay. Oops. Sorry. All right, so what are we going to do? We're looking for Wikipedia page. And so obviously an acronym like that's going to have lots of entries. So we come down to science, and that's the one. Now, how are you going to know that? Well, just a little practice, right? Stick with your science. So basically, the circles are nodes, the lines of edges were also called, and so basically a cyclic graph, A would connect to B, B would connect to D, D would connect to C, and then C would connect back to A. That's a cycle. So an acyclic graph, if you notice, the arrows don't go back. So that's kind of like a pedigree, right? And so that's all that meant when we come back to this, when we're talking about an ancestral recombination graph. It's a graph in which you have nodes, which would be individuals. And individuals then connect forward to their own children and backward to their own parents. And so that's where the acyclic part comes from. There's no cycle, but the arrows are the directed part. Okay. All right, so what else we've got here? Blah, 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 blah. Okay. Coming through here. Pardon the scrolling. So we had genetic ancestry, so we're talking about the inheritance of haplogroups. Ancestral recombination graph, that's we're trying to connect those haplogroups. Okay. And finally, what we're going to be reading through there is, of course, they're defining these things, but then they're going to basically start saying, but even this isn't going to, we can't reconstruct pedigrees, if you will, by just simply looking at chunks of DNA. We can do it for a few generations because, sort of along the lines of that simple 2 raised to the n, go back just a few generations and you're actually talking about people. But when you go back multiple generations, you're going to go back into, in fact, you can't really identify individuals. You have populations, and those populations are a mix. In genetics, we call it an admixture group. Okay? And so what we're hinting at is then we're starting to talk about how 23andMe, so the consumer product stuff, how they talk about ancestry. Okay? Admixture, that's basically a program for doing these kinds of things. So this graph is about trying to relate the admixture graphs in terms of connecting those different haplogroups and whatnot, and sort of making inferences about ancestry. Okay, so long-winded way of going about this, where we're sort of wrapping this up. The other thing that the problem with this is that, of course, we have categories for populations. We'll say things like European or African, Native American, and the thing about that, though, is that those are not necessarily genetic groups. So the way this comes out is we don't actually have, specific markers for different populations. So what we're going to end up doing somewhere in here is we're going to talk about genetic similarity. So genetic similarity is you collect alleles, markers, and then you do, in effect, a correlation analysis, and you say, okay, this individual has these haplogroups, so that makes them most similar to this group. And that's, in effect, what 23andMe is doing, which is to combine our individual genetics into a projection back into the past and saying, well, what similarities do you have with these groups? Okay, so that leads into some other things, right? So you're kind of working through this, and I want you to pick out the topics that interest you and then kind of dig deep into those words and phrases that don't make any sense, and that can then show you a way through. So one of the things that I would suggest as a topic would be, well, let's find out what does 23andMe actually do? how many populations do they actually sort of represent? How do they do that? And so you can go to their consumer page and you'll find that the reference populations that they use go to about 45 different geographic areas, regional areas. And then they've added in the last couple of years what they're calling recent ancestor locations. And so they've added, when I checked that today, that was 115 of these recent ancestor locations. And so from that, that's how they're going to reconstruct your ancestry. And you end up getting those numbers like I showed you my pictures. Let's see, where is this? Okay. Oh, it's in this first day slide, so you'd have to actually go and watch the video, right? So let's see if we can find that quick. That's right, we had some problems with that. Yeah, okay, so we can kind of stop there. Oops, too far. Yeah. So 23andMe said that my ancestors come from this area. 23andMe then gave me this data, which represents the haplogroups that they identified. Okay, so that's something you can do. Anyway, let's go ahead and kind of sign off here. Start with the readings. Pick out the words that you don't understand and see if you can dig down, and that's a project. Okay? So I will talk to you again on Tuesday, and have a nice day.